Hi, today I'm going to show you how to do practice problem 13.3 from Fundamentals of Electric Circuits. First, we need to find the coupling coefficient of the circuit. So we're going to use the formula K is equal to the mutual inductance divided by the square root of inductor 1 times inductor 2. It's going to be equal to K is equal to 1 Hertz divided by the square root of 2 times 1. This is going to give us 1 divided by the square root of 2, which simplifies to 0.7071. And this is our coupling coefficient. First, we need to find the frequency domain equivalent. We can do this by taking into account at first the angular frequency, which in this instance is 2 radians per second. Now we begin our conversion by taking into account the impedance from inductor 1, inductor 2, the mutual inductance, and the inductance of the capacitor. So the impedance of L1 is equal to j omega L1. This is going to turn into j times 2 times 2, which is going to give us 4j. Now we need to find the impedance of L2. Where it's going to follow the same formula where XL2 is equal to j omega L2. So this is going to give us j times 2 times 1, which is going to give us 2j. Next, we need to find the impedance of the mutual inductance, which tells us that X of M is equal to j omega L2. Or actually, it should be Lm, which is 1 in this instance if you look at the circuit. But j times 2 times 1 is j2 omega, so it's still the same. And then we need to find the impedance of C, or the capacitor. This is going to give us XC is equal to 1 divided by j omega C, which in this instance could be 1 times j times 2 times 1/8, and that's going to give us negative j4 omega. Here I've redrawn the circuit, and I now need to account for the mutually induced voltages at j2 omega. So first I pay attention to the polarity on the right side, plus minus, plus minus, plus minus. I pair the plus and the dot, and I carry it to the opposite side. I pair them together, and I shift it upward, and that's going to be my dependent voltage source, which is going to be J2I2. Next, I'm going to measure the polarity on the left side, so plus minus, plus minus, plus minus. I'm going to pair the dot and the negative, carry it to the opposite side, mark it minus and plus, pair them together, and then shift upwards. And that's going to give me my other dependent voltage source. Next, I'm going to perform a KVL at loop 1. So this is going to be negative 100, angle 0 degrees, plus 4 minus J4 plus J4, all times the current of I1, minus J2I2. And this is all going to be equal to 0. This is going to simplify down to 4I1 minus J2I2 is equal to 100 angle 0 degrees. Next, I perform the KVL at loop 2, which is going to be 2 times I2 plus J2I2 minus J2I1. And this is all going to be equal to 0. I'm going to pull out the I2, and I'm going to I2 times 2 plus J2 is equal to J2I1. This can be simplified down to I1 is equal to 2 plus J2 divided by J2, all times I2. This finally simplifies down to 1 minus J1 times I2 is equal to I1. Next, we're going to use the two equations to solve for I1 and I2. So we're going to look at this first equation here, and we're going to plug in I1, and we're going to get 4 times 1 minus J1 times I2 minus J2I2 is equal to 100 angle 0 degrees. This turns into 4 minus J4 minus J2 all times I2 is equal to 100 angle 0 degrees. Now we can rewrite this where I2 is equal to 100 angle 0 degrees divided by 4 minus J6. Now we need to convert this to polar coordinates so we can divide. So we know that the equation theta is equal to the inverse tan of negative 6 divided by 4. This is going to give us negative 56.31 degrees. Next, we need to solve for r, which is square root of x squared plus y squared. This is going to give us the square root of 4 squared plus 16 squared, which is 7.21. We then plug this in, so we'll get 7.21 angle negative 56.31 into, and swap it with the 4 minus J6. We're then going to get 100 angle 0 degrees divided by 7.21 angle negative 56.31 degrees. This is going to give us 13.86 angle 56.31 amps. And this is going to be our I2 value. Next, we're going to need to solve for I1 since we already have I2. So our equation for I1 is equal to 1 minus J1 times I2. So if we plug in our given I2, we're going to get I1 is equal to 1 minus J1 times 13.86 angle 56.31 degrees amps. Now we need to convert this to polar coordinates, so we're going to do the square root of x squared plus y squared, and this is going to give us our r value of 1.41. Then we need to find a theta, so the inverse tan of negative 1 divided by 1 is going to give us negative 45 degrees. And this is going to be our theta value. So this can be written out as 1.41 angle negative 45 degrees. This gets replaced with the 1 minus J1, and our I1 can be written as I1 is equal to 1.41 angle negative 45 degrees times 13.86 angle 56.31 degrees. In total, I1 is equal to 19.61 angle 11.31 degrees. And this is our I1 value. Here's our I1, here's our I2. With this given information, we can rewrite current I1 and I2. I1 is equal to 19.61 cosine of 2t plus 11.31 degrees amps. And I2 can be written as 13.86 cosine of 2t plus 56.31 degrees. And this is amps. Now we need to solve for I1 and I2 at the given time periods, which is 1.5 seconds for this problem. So I1 is going to be equal to 19.61 cosine of 2 times 1.5 radians times 180 divided by pi plus 11.31 degrees. This is going to give us 19.61 cosine of 171.88 degrees plus 11.31 degrees amps. This turns into 19.61 times negative 0.9984. And this is amps. This gives a final solution for I1 at 1.5 seconds to be negative 19.58 amps. Now we look at the I2 value. I2 at 1.5 seconds. So I2 is going to be equal to 13.86 cosine of 2 times 1.5 radians times 180 divided by pi plus 56.31 degrees amps. This simplifies to 13.86 cosine of 171.88 degrees plus 56.31 degrees amps. This simplifies down to 13.86 times negative 0.666, which gives I2 at 1.5 seconds negative 9.25 amps. Next, we need to find the total energy stored in the coupled inductors. For this problem, we'll be using the equation W is equal to 1/2 L1 I1 squared plus 1/2 L2 I2 squared minus the mutual inductance times I1 times I2. This becomes 1/2 times 2 minus 19.58 squared plus 1/2 times 1 minus 9.25 squared minus 1 times negative 19.58 times 9.25. This simplifies to 1/2 times 2 times 383.4 plus 1/2 times 1 times 85.19 minus 1 times 180.72. This simplifies down again to 383.4 plus 42.6 minus 180.72, which gives us 426, minus 180.72, which gives us 245.3 joules.